Hello everyone, my name is Prashant Shargave and today I will be explaining the topic confusion matrix and model evaluation matrix. In machine learning, building a model is only half part. The most important part is evaluating how well the model performs in real world conditions. Just knowing that a model is accurate is not enough. We must know how and where it makes mistakes. Proper evaluation ensure that our model is reliable, trustworthy, and can generalize well to unseen data. That's why we move beyond the simple accuracy and use detailed evaluation metrics. Let's see why only checking the accuracy can be confusion. Accuracy means how many times the model gives the correct answer out of all the prediction. But imagine a model for cancer detection if it's a no cancer for every person and 95 out of 100 people really don't have the cancer. The accuracy will be still 95%. That's look very good, right? But the model did not find even one real cancer patient. So accuracy alone does not tell the full truth. It can be high even when the model is doing poor job, especially when one type of data is much larger than the other. This is called an imbalanced dataset. To solve the problem of depending on the accuracy, we will use something called a confusion matrix. It's simple 2 by 2 table that compare the what the model predicted and what was the actually true. This helps us to understand how well our model is performing in the details. Let's look at with an example. In this table, we have 192 total predictions made by the model. The row shows the actual value and column shows the predicted value. In this matrix or table, there are four main terms. True positive. These are the use cases where the model predicted actually was positive and actual value also positive. The model correctly, in this example, the model correctly found the 15 people who truly had the diseases. Second, true negative. These are the use cases where the model predicted is negative and actual value also negative. In this example, the model correctly identify the 118 people who did not have the disease. False positive. These are the cases where model predicted positive but the actual value was negative. In this example, the model said 12 people had the disease but they were actually healthy. This is called an type error. False negative. These are the use cases where model predicted negative but actually value was positive. In this example, the model missed 47 people who actually had the diseases. This is called a type second error. Now let's understand how we calculate important evaluation metrics using the confusion matrix. This matrix helps us to know how well our model is predicting and where it is making the mistakes. First, precision. Precision tells us out of all the cases that model predicted as a positive, how many were actually positive. In simple words, if our model says yes 10 times, how many of those yes were predicted correctly? It uses formula true positive divided by true positive plus false positive. Second, recall. Recall tells us out of the all the actual positive cases, how many did the model find correctly? In simple words, if there are 62 real positive cases, how many did the model successfully catch them? It uses formula true positive divided by true positive plus false negative. F1 score. F1 score combines both precision and recall into one single numbers. It gives the balance between them, especially when your data is not equal or imbalanced. It uses formula 2 into precisions into recall divided by precisions plus recall. For the accuracy, accuracy is the most basic metrics. It tells us how many times the model predictions was correct overall, both for positive and negative. It is this formula true positive plus true negative divided by total samples. Even the confusion matrix is very useful tool, it also has limitation. Things we must be careful about the confusion matrix. First, imbalanced data bias. Sometimes one class has many or more sample than the other. This is called as imbalanced data. For example, there are 95 healthy people and only 5 sick people. In this case, the model get high accuracy by simply predicting the majority class that is a healthy for every times, but it still fails to detect the minority class that is the sick class. Second, multi-class complexity. The matrix is easy for two classes like a 0 and 1, but when we have multiple classes, for example classifying the fruit as apple, banana, mango and orange, the matrix become very large and difficult to read. To solve this problem, we use methods like macro averaging. Third, threshold depending. Some metrics like precision recall depend on cutoff value, which is called as a threshold. For example, deciding if the deciding that if the model confidence is above 0.5, it predict yes, otherwise no. If you change the threshold like 0.6 or 0.4, the precisions and recall values will also change. To handle this, we use another matrix called AEUC, which checks all the model performance, all the possibility of threshold to give fair comparison. Lastly, to summarize, the confusion matrix is the foundation of evaluating the classification models. Metrics like accuracy, precision, recall, and effort scores help us to measure the performance more meaningfully. The choice of metrics depend on the problem type or the balance or imbalance dataset. Proper evaluation ensure that our AI models are fair and reliable in and trustworthy. Thank you.